Alright, you're welcome to my YouTube channel. Remember, I'm still the boiling point. Please, if you've not subscribed to my YouTube, please do that. Remember the name, The Sky Academy. That is my YouTube channel. Please subscribe. I beg you. Okay, we've been solving questions under circular motions. And by God's grace, I've been able to solve questions from question number 1 to question number 5. And this is the continuation, which is number 6. So we're going to be continuing with the question. Please, if you've not watched my video, that is my first video on that circular motion, please do well to go and watch it. You get it? Please go and watch it. Okay, let's start with question number 6. Question number 6, they say, which of the following quantity remains constant in uniform circular motion? Let me underline this. Uniform circular motion. Please underline that word. Uniform circular motion. Option A, they say velocity. Option B, they say acceleration. Option C, they say speed. Okay, this is speed. Option C, they say speed. And option D, they say momentum. Very interesting, right? But let's see how we can be able to break this thing down so that you will understand it very well, please. And a lot of questions will come out from this aspect of physics. So, and apart from this question, please, I want you to understand more things deeper than this. So they said uniform circular motion. So for you to be able to understand uniform circular motion, I think the first thing you need to understand is uniform motion first. Let's understand what is called uniform motion. So please, what is called uniform motion? Anytime you hear the word uniform motion, it is also known as constant motion. So if you don't call it uniform motion, you call it constant motion. So why is it called a constant motion? Because it occurs under a constant conditions. So there are 3 properties or the 3 characteristics of a uniform motion. Number 1 is that the speed is constant. So for you to say that the motion is uniform, that means the speed is constant. That is number 1. Number 2, the velocity is also constant. Yes. Number 3, there is no acceleration. There is no acceleration. So for you to say a motion is constant, it is either the speed is constant, or the velocity is constant, or there is no acceleration. And this is where the options becomes a little bit difficult, because if you watch, there is velocity there is acceleration here, there's speed here. So how do you analyze this question? Please listen. First of all, let me start with this concept. This speed you're seeing here, remember, is a scalar quantity and not a vector quantity. So speed is a scalar. So if speed is a scalar, it means that speed has what we call magnitude only. They have what we call magnitude, and they don't have direction. But you see, velocity and acceleration both are vector quantity, and they have what we call magnitude and direction. They have what we call magnitude and direction. So note number 1 here. Speed has magnitude. So the only thing that speed has is called what? Magnitude. That means I can say that speed is also equal to magnitude. So if speed is magnitude, that means any place I see magnitude, can I put speed? Yes. So remember that velocity is equal to magnitude plus direction, right? That means they have magnitude and direction. If velocity is equal to magnitude and direction, that means velocity can also be this magnitude, remember, is called speed, can also be speed plus direction. So if they ask you to define velocity, Velocity will now be a speed that has direction. A speed that has direction. So any speed that has direction is called what? Velocity. So note this. Number 2 thing I want you to know is the concept of acceleration. Now, you know that acceleration, which is A is change in velocity over time. That means for you to have an acceleration, the velocity must change. In physics, there are 3 ways in which velocity changes. Please. There are 3 ways in which you can change velocity. The first way in which velocity can change is either the magnitude of the velocity is changing. Either the magnitude of the velocity is changing. What do I mean by this? Okay, let me clear here and explain further. What do I mean by this? Listen on attentively. What do I mean by this? Let me say a car started from point A and moved to point B, and from point B it moved to point C. So let's get the direction of the car. That means the car is moving towards the east. So a car from point A to point B is moving towards the east. A car from point B to point C is also moving towards the east. That means they are moving in the same direction. Now let me say at point A, the velocity of this car was 2 meters per second. That is the magnitude. At point B, it was 5 meters per second. At point C, it was 10 meters per second. What did you observe? You observe that in this, the magnitude of the velocity is changing, but the direction remains constant. Now, at point A, the magnitude was 2. Point B, it was 5. Point C, it was 10. So what is happening? You discover that the magnitude is increasing. And if the magnitude is increasing, we will say there will be acceleration. So the number here increased to 5 and increased to 10. So there is acceleration. So acceleration can occur when the magnitude of the velocity changes, irrespective that the direction is the same. That is number 1. Then velocity can also change in terms of direction. In terms of direction. So it is possible for us to have the same magnitude but different direction. Okay, for example, let's say the same thing here, that the body is moving from point A to point B and from point B to point C. So this body moved from point A to point B and from point B to point C. And let me say the magnitude of point A is 2 meters per second. For point B is 2 meters per second. For point C is 2 meters per second. So what did you observe? You observe that the magnitude of the velocity is the same, but the direction are changing. In this case, the magnitude is the same, but the direction is changing. There will still be acceleration. Are you getting me now? So acceleration can either be as a result of change in magnitude only, or change in direction only, or both. Both are changing. There are situations where from point A to point B, from point B to point C, there is change in direction. Then from here at point A it was 2 meters per second, at point B it was 5 meters per second, and at point C it was 10 meters per second. So what did you observe? In this case, the magnitude is changing, the direction is changing. So both of them are changing. So if both of them are changing, there is a change in velocity. And if there is a change in velocity, there will be acceleration. Did you get that now? So the reason why I'm explaining this way is because we want to understand the concept of circular motion now. So in the concept of circular motion, that means I have a body that is undergoing circular motion. Now, this is the body that is undergoing circular motion, and this is the center of the body. And remember, from the center of the body to the circumference is called the radius. Now, let me say that the body was here. So this is my point A. And this body moved from point A and get to point B. So this is another body. This is the same body but at point B. And let me say that the velocity at this point is 2 meters per second. The velocity at this point is 2 meters per second. You get it? What will you observe? You observe that the magnitude of this velocity is the same. Why? Because at point A it was 2 meters per second. At point B it was also 2 meters per second. So what is not changing in this circular motion? The thing that is not changing in this circular motion is called the magnitude. The magnitude. That is the only thing that is not changing. I remember in what I did previously before I cleaned the board. Now, I told you that this magnitude is also known as speed. So what is not changing in this body can also be called speed. For the fact that the magnitude is the same, that means the speed is also the same. But guess what? A body that is undergoing circular motion must always change direction. It's a must. So this body that is moving in circular motion, the body is always changing direction. If the body is changing direction, that means the magnitude is the same. The magnitude is constant. That means same. But the direction is changing. Are you seeing that now? So speed is constant, but the direction of the body is changing. And remember, if the direction of the body is changing, what are we going to have? We'll have acceleration. So at this point, in which the magnitude of this body is the same, but the direction of the body is changing, there will be acceleration. That acceleration is called centripetal acceleration. What is it called? Centripetal acceleration. Now, it is called centripetal acceleration because it is moving towards the center. It's called center-seeking acceleration. So this centripetal acceleration is as a result of change in the direction of the body. So the body is changing direction. And if the body is changing direction, that means an acceleration will occur. And that acceleration is called centripetal acceleration. So the only thing that is not changing here is just the magnitude of that body. And the magnitude of that body is the speed. And if the magnitude is not changing, remember, and the speed is not changing, that motion is said to be uniform circular motion. What is it said to be? Called uniform circular motion. So in uniform circular motion, the only thing that is left constant is the speed. Speed is not changing, which is as a result of the magnitude. But velocity is changing. Acceleration is changing. You get it? But the speed is not changing. Do you get that now? So the only thing that is constant there is speed. So that is that. Question number 7. Question number 7. Question number 7. What do we have? We have that the acceleration of a body in uniform circular motion is dash. The acceleration of a body in uniform circular motion is that. Option A, tangential. Option B, radial, which is centripetal. Option C, both tangential and radial. Option D, 0. Thank God we are able to do what we call uniform circular motion. And I told you that uniform circular motion, the only thing that is constant there, please note it, the only thing that is constant there is the magnitude, which is the speed. So if the magnitude is constant, that means the direction is changing. And if the direction is changing, there will be an acceleration as a result of change in direction. That acceleration as a result of change in direction is called centripetal acceleration. Are you getting it now? So here the correct answer is radial. Why is it called radial? Because it's moving towards the center, radially inward. Do you get radial inward? Now the word radial means that it is moving inward. That's what it means. So you have in biology we have what we call ulnar and radius bone, radial bone. You get it? Can you still remember? So if you check your radial bone, you discover that it's moving towards the center. So please note it that the correct answer is option B. Why? Because it is moving towards the center. Please note it. So when a body, this is number 8, when a body moves in a vertical circle, The tension in the string is A, constant throughout, B, greatest at the bottom, C, greatest at the top, D, 0 at the bottom. How do you solve this? Listen. Now, this question, they said a vertical circle. That means circular motion. That means circular motion is divided into two. We have what we call horizontal circular motion. Then we have vertical circular motion. What is the difference between these two? Horizontal is moving in X direction. Vertical is moving in Y direction. So this is horizontal now. You get it? Why this one is vertical? So this question now that you're seeing on the board is actually coming from vertical motion. So if it's coming from vertical, that means I'll have this. The body is undergoing vertical circular motion. So in vertical circular motion, here at this point is called the top. It's called the top. At this point, it's called the bottom. So we have the top, we have the bottom. Here now, it's called the center. It's called the center. So remember, I have a rope. I'm using a rope, and this rope is tied to this body, and this body is moving in a vertical plane. So any body that is moving in a vertical plane, also moving in a circular motion, is called vertical circular motion. So the rope will also be here. So this is the rope that's moving this object. Now, what will you observe? You observe that there is a force that is provided by this rope. The force that is provided by this rope is called tension force. What is it called? Tension force. So at the top, you discover that this force is moving down. So the tension force is moving down. T is moving down. That means the direction of the tension force is downward. Please note it. Now, you discover that when the body is also at the top, it is acting towards gravity. So there is a force that is also pulling the body downward. Not just the rope only. The rope, which is the tension force, is pulling the object down. Then there's another force that's also pulling the object down, which is the weight. So I have two forces that are pulling the object down. Both the tension and the weight. And both of them are moving towards the center. So if they are moving towards the center, that means they are moving, they will produce a force called centripetal force. But at the bottom, when it's at the bottom, you discover that the weight of this object will be moving down. At the bottom, the object wants to go up. So when the body is at the bottom, the weight is going down, but the rope is pulling it up. So, and the rope is provided by the tension force, which is T, is moving up, but the weight is moving down. But at the center, the only thing that is acting here is the tension force. So in summary, what will I say? I will say at the top, which is here, I have two forces that are moving down, and these forces are moving towards the center. So that forces are the tension force, which is T, plus the weight, and both of them is moving towards the center. That means both of them will combine together to form what we call centripetal force. You get it? So what do? Make tension the subject of the formula. That means tension will now be equal to force, that is centripetal force, now plus W crossing the positive sign will be minus what? W. I'll have it this. So I have minus. So at the top, the tension force is said to be minimum. Why? Because of the presence of this minus. At the bottom now, you have two forces that are moving in opposite direction. What do? You subtract. Because these two forces are moving in opposite direction. The tension is moving up, the weight is moving down, so they are moving in opposite direction. What do? You subtract. So if you subtract, that means at the bottom, at the bottom, what am I going to have? I will have that the tension minus the weight. Why are you subtracting them? Because both of them are moving in opposite direction. Remember, the weight is acting downward, the tension is acting upward. So, which is equal to the centripetal force. So, if you make tension the subject of the formula, you have the centripetal force, then minus weight crossing equality sign, B plus weight. So, what did you observe? The tension at the bottom, there's positive here. That means the tension here is said to be maximum. Why is it maximum? Because of the presence of plus. But at the top, the tension is said to be minimum because of the presence of this what? Minus. Why at the center? That means at the center here, center, what do you observe? At the center, you observe that the tension will be equal to the centripetal force. So please note this. So let's go back to our question. The question says, when a body is moving or moves in a vertical circle, the tension, vertical circle, the tension in the string is it constant throughout? Of course, it's not constant. At the top, it is minimum. At the bottom, it is maximum. So it is not constant. B, it is greatest at the bottom. Is it true? Okay, let's go at the bottom. Yes, it is greatest at the bottom. So this answer is correct. That means B is correct. It is greatest at the top. It is not greater at the top. Why? Because of the presence of this minus. So it is minimum at the top. Then D, it is 0 at the bottom. No, it can never be 0. So the correct answer is option B. Please note it. Then question number 9. Question number 9. I have that a body moving in a circular path with increasing speed has dash. A body that is moving in a circular path with increasing speed, what do they have? Option A, they say only centripetal acceleration. Option B, only tangential acceleration. Option C, both centripetal and tangential acceleration. Option D, no acceleration. So how do you solve this? Now, a body is moving in a circular path with increasing speed. If the body is increasing in speed, that means the magnitude is increasing. What does it mean? It means I have a body. This is the body. And this body is undergoing circular motion. So this is the body undergoing circular motion. And this body at point A, let me say, when I check the magnitude here, it was 2 meters per second. Then it now moved to point B. At point B, the magnitude here was 10 meters per second. What did you observe? The body is moving with an increasing speed. That means the magnitude is increasing. So here, the magnitude is changing. Magnitude is changing. If the magnitude of the velocity is changing, there will be acceleration. So the acceleration due to the change in magnitude is called tangential acceleration. What is it called? Tangential acceleration. So note it. Number 2, it is not just the magnitude that is changing. The direction is also changing. Why? Because the body is undergoing circular motion. So any body that is undergoing circular motion, the direction must change. So the direction here is also changing. So if the direction is changing, the direction is changing. If the direction is changing, there must also be an acceleration. And that acceleration, which is due to change in direction, is called centripetal acceleration. Centripetal acceleration. So what does it tell you? It tells you that if the magnitude of the body undergoing circular motion changes, there will be acceleration. That acceleration is tangential acceleration. Why? If the direction of the body changes, which is a must in circular motion, there will also be an acceleration. That acceleration is called centripetal acceleration. So tangential acceleration is due to change in magnitude of the body. Why centripetal acceleration is due to change in direction of the body. Are you understanding what I'm saying? I know, of course, you're understanding it. So A body moving in a circular path moves with increasing speed has only centripetal acceleration. No, it will only have centripetal acceleration if the speed is constant. B, only tangential acceleration. No, it will only have tangential acceleration if the body just increases in speed and the direction is not changing. Option C, they have both centripetal and tangential acceleration, of course. Both of them will have tangential and centripetal acceleration. So question number 10. Question number 10 is that a 2 kg mass attached to a string of length, 1 meter, is wheeled in a vertical circle. If it is vertical circular motion. At the lowest point, its speed is 8 meters per second. That means at the lowest point, at the bottom here, the speed is 8 meters per second. What is the tension in the string at the lowest point? So we are looking for the tension at the bottom. So if we are looking at the tension at the bottom, that means we apply this formula. We are looking for the tension at the bottom. Let's apply this formula that is here at the bottom. So what will be the tension at the bottom? We'll have that the tension at the bottom will now be T is equals to, I have centripetal force plus weight. Recall that centripetal force is equals to mv square over r. And also recall that the weight is equals to mg. So what does it mean? It means any place I see centripetal force, what am I going to put? mv square over r plus what of weight? mg. So with this, we can be able to calculate the tension at the bottom. So let's impute those values. First of all, bring out your data. What data did they give us? First of all, they gave us mass. Mass is here, which is 2 kg. Mass is 2 kg. What again did they give us? They gave us the length, which is the radius. The radius here is 1 meter. Then at the lowest point is speed. That means they gave us the speed, which is 8 meters per second. So, and they gave us g, which is 10 meters per second squared. So I say we should calculate the tension, which is unknown. That means I will apply this formula. Tension will now be equal to, what is the mass? 2 times, what is the velocity? A square all over 1 plus mass here is 2 times 10. So how do we solve this? You have that the tension is 2. What is 8 square? 8 square is 64. Then plus 2 times 10 is 20. Remember, over 1 will still give you the same thing. So 64 times 2. 64 times 2, that is 128. I will have it that tension is equals to 128 plus 20. So 128 plus 20, tension will now be 148 Newton. Do we have anything like 148 Newton? Option A is 128 Newton. It can never be the answer. Option B is 148 Newton. Yes, option B is the answer. So there is no need for us to further more. So thank you. This is the last section of this circular motion. Thank you, and wait for your simple harmonic motion. God bless you. Thank you.